All right, good morning. So we're moving on to the next lesson, which is 1.3, and we're going to be translating verbal phrases into expressions. So just to review a little bit of the vocabulary with this lesson, we're going to talk about verbal models. A verbal model describes a situation using words as labels and then using math symbols to relate those words. Then we will also get into some rates and unit rates. A rate is simply a fraction that's comparing two quantities that are measured in different units. And then we'll talk about unit rates, which are rates whose fractions have a denominator of 1. But first, let's talk about some of the common verbal terms that are used to indicate different operations. So the first operation that we'll talk about here is addition. So some of the terms that, or words I should say, that refer to addition would be obviously add, or any version of that word, like in addition to, or something like that. Some indicates that we're going to be adding something, maybe the word plus, more than, also increase or any other version of that word. So maybe increased by or increasing or something to that effect. Okay, the next operation we're going to talk about is subtraction. So some of the verbal terms that refer to subtraction, of course, are subtract or any version of that, subtracting, subtracted, whatnot. Then difference. Finding the difference means that you're going to be doing subtraction. Less than, minus, take away. What else? Oh, and reduce or reduced by, any kind of version of that word, and also decrease or decreased by or any version of that word. So now let's talk about multiplication. So for multiplication, of course, we have multiply or times. Those are pretty common ones. But product is a word that we use to talk about the answer to two things that are being multiplied. Some other words would be the word of. So of is commonly used when we're referring to percents, because we might say like 30% of 100 or something like that, and that of indicates that we would have to multiply those numbers. Anytime we talk about something being doubled or tripled, that would indicate multiplication. And I'm trying to think if there's any that I forgot. All right, so that's it for now. Okay, then let's talk about some division terms. So, of course, we have divide. The word that indicates that division has to happen is quotient. And some other words that you might see would be if you're going to split something. So if you're going to split something amongst 4 people or something to that effect. And then it might be more specific, like if you're going to half something or, cut something into some sort of fractional amount, then you're dividing. And another one would be the word per. So we'll talk about this one a little bit more when we get into our unit rate, because that does involve division, and we are going to use that word per frequently there. Okay, then we talk about parentheses or any grouping symbols. So as we did in a previous lesson, we also had some brackets there and things like that. So it doesn't really matter what type of grouping symbol we're using. I'm just calling them all parentheses for now. The main thing that we'll see that indicates that there's that is if you see the words the quantity of something along those lines, that typically indicates that we need to put whatever that is in parentheses. Now, very often when we look at verbal situations that are going to require parentheses, when we put them into our algebraic models, it doesn't specifically tell us, but there'll be some indication of something happening first. And I'll show you when we do some examples in a minute. But if something is happening first, so for example, if I said 2 times the sum of 7 and a number, well, you'd have to find that sum first. You can't multiply 2 by the sum until you actually do the sum. So that would tell you or give you a hint that you might need to put that in parentheses. And then finally, the last thing we're going to talk about is our exponents, which we did talk about some of these terms in the lesson 1.1. So we could talk about powers or raised to, I'm trying to think of another word, maybe squared, if it's raised to the second power, or cubed. Those are some different words that we used to indicate that there will be exponents involved. So take a looking at the first example here. We're going to translate these verbal phrases into expressions. So the first thing I might kind of look for is some of those words that we just talked about in that chart. So we have 8 more than, so we know there's probably going to be some addition involved there. Then we have the product of 5 times the number W, so we know there's some multiplication in there. So usually what I try to kind of maybe like separate this into what's happening, right? So it's 8 more than, so we know that there's going to be 8 added on to something. Then we have the product of 5 times a number W. So the 5 times a number W would look like that, 5W. Some people might want to put a times sign in the middle. You can, but it's not necessary. Or parentheses around the W or something. Again, you don't have to. Then we know that the 8 more than is going to be an 8 being added somewhere. Now, some people might want to write 8 plus 5W. And while that's not wrong per se, because addition can occur in either direction, forwards and backwards, and you're still going to get the same answer. But whenever we talk about 8 more than something, like if I said, he has 8 more cookies than you, well, you'd have to know how many cookies you have first and then add the 8 onto that. So typically when you see the word more than, that is the one instance in addition where technically you should be adding it to the end. The same thing happens in subtraction when you see the words less than. So if you take a look up here on my little chart, I'm just going to highlight those two, the more than, and the less than. All of the other addition and subtraction words, you pretty much are going to do in order from left to right. So whatever comes first would come first in your expression. Whatever comes second would come second in your expression. The only time we deviate from kind of going through the problem and just writing it as we see it is the words more than and less than, and that's when that number should be added or subtracted at the end. Now, again, the more than, you're not going to be wrong technically if you put it in the beginning, but if it's a multiple choice, the answer will be written the way I'm telling you about it at the end. So just keep that in mind for those two. Okay, so now the next one, we have the quotient. The quotient indicates some division is going to happen. So it's the quotient of 11 and the sum of 7 and a number x. So we have two numbers going on. We have the 11 and we have the sum, that's the second term here, the sum of 7 and a number x. Now sum means addition, so I'd have to write 7 plus x. Now if I want to divide these two things, I could just put a divide sign in there. And again, I would have the 11 come first and this part comes second because you typically are going to do it in the order that you see it. The only problem with this is the sum has to be found first. You can't divide 11 by something. You can't divide 11 by 7 or by x. You need to find the sum of those two things. So if we're writing it horizontally like this, we would need to put that in parentheses to make sure that that happens first. Now the other option for division here would be to write it as a fraction. And if you write it that way, and you forget the parentheses, it's not that big of a deal because the fraction bar is already separating it. And remember, everything has to be simplified on one side of the fraction bar before you can actually do any division or simplifying. All right, so then we have the next one here, the square of a number y, that's our first number, right, is decreased by 13. So we have the square of a number y, so that's our exponent, y squared. decreasing something is subtracting, and you're going in order from left to right as you see it as it comes. So y squared minus 13. Okay, so now we're just going to do some practice examples. Okay, so the first one here, the difference, that tells us there's some subtraction of 3 times a number n. So we know there's some multiplication. So the difference of 3 times a number m and 5. So these are the two things we're finding the difference of. The 3 times a number m and 5. And because they came in this order, the 3 times the number m came first, the 5 came second, so that's the order that I would subtract them in. All right, the next one, 26 divided by a number n. So this one, there's really nothing tricky about it. You're just going in order, 26 divided by n, or of course we could write it with the fraction bar using that as our division sign. Okay, number 3, 1/3 of. So when we see that word of, like I mentioned to you earlier, that's going to indicate that we're going to do some multiplication. So this could be 1/3 times p. It could be 1/3 times p like this. It could just be 1/3 p. You don't really need a multiplication sign or parentheses when you're just multiplying two things. When you smush them up next to each other like that, it indicates multiplication. Now, if you were to simplify 1/3 p, 1 times p would be p, and on the bottom here you have 3 times 1, which is just 3. So you could write that as just p over 3. Anytime you have like 1/2 times a variable, or 1/3, or any kind of fraction with a 1 in the numerator, you can just write the variable on top of the denominator. Okay, number 4, the sum of 9 and the square of a number k. So I highlighted the two numbers or variables that we're using. So the and is telling us that these are the two separate things, and we're finding the sum of those. So we're adding the 9 and the square of the number k. And again, I'm just going to go in order as they come. So the 9 came first, the square of the number k came second, and then I put the plus sign in between. All right, number 5, the quotient when the quantity 10 plus a number x. So this is telling me that this piece is going to have to go in parentheses. So I have the quantity 10 plus a number x. So 10 plus x, and then it says is divided by 2. So is divided by 2. And as you probably know by now, I prefer to write these using the fraction bar as my division sign, like this. And if you write it that way, you can have parentheses or not. Okay, if you write it horizontally, like I have over here, you would have to have the parentheses there. I always put them. It's always better to have them than to not, because if you're not sure, then make sure you have them. Okay, the next one here. 8 times the quantity 4 plus a number n. So right away we'll take care of that piece. 4 plus n, and I put it in parentheses because of that word quantity. And then it says 8 times. So you might want to write 8 times like that. But again, when you're multiplying two things, you can smush them right up next to each other, and that indicates the multiplication. So we can really just write 8 parenthesis 4 plus n, close that parenthesis. Okay, number 7. 12 decreased by a number x. That's just straightforward 12 minus x. And then the last one, the quotient of, so we know we're dividing, the square of a number w and 5. So those are those two things that we're dividing, right? the square of a number w would be w squared divided by 5, but I prefer to write it with the fraction bar like this instead. All right, so moving on to our next example, we're going to do some actual word problems where we're writing an expression to represent that situation. So for this one here, it says a student reads P pages of a 230-page book. Write an expression for the number of unread pages. So if you think about this just logically for a second, if you had a book you had to read for summer reading and you had read a certain amount and you're like, oh, how many pages do I have left? You would probably say, okay, well, what are the total pages? You'd probably look in the very back of the book and see what's the last page, right? And you would subtract however many you've read, and that would tell you how many you have left. So in this case, to use this verbal model here, the total pages was 230, and then if I subtract P pages representing how many I've read, this expression now, 230 minus P, would represent how many pages I have left to read in that book. So if we take a look at some more of these types of examples, if we're looking at number 9, the total cost, I want to find an expression to represent the total cost of n notebooks if each one costs $125. So if you go to the store and there's a stack of notebooks, let's say you're at Target or wherever you go shopping for your school supplies, and you're like, oh, I need 5 notebooks, right? Well, each one's $125. So how would you figure out what you're going to need to pay for these notebooks? You maybe want to figure out, oh, do I have enough money or whatnot? So you would have to take the cost, $125. So the number of notebooks, and you would multiply that by the price of each notebook, and we know they're all the same. So there's n notebooks, and we're going to multiply that by 125. Now again, we don't need a times sign there or anything. And so I'm just going to simplify. Now usually in algebra, when we're multiplying things, we put the number in the front and the variable second. That's just the standard form of how we write those answers. It's good to get used to that only because if you're doing any types of multiple choice quizzes, tests, or whatever, the answers will always be in that preferable standard form. Okay, the time it takes to get to school and home again if you walk 5 minutes to the bus stop and then ride the bus, right? So let's say here's your home. Here's the bus stop. I'm going to draw my little sign here. Okay. And then here's school. All right, there's school. This is home. So we know it's going to take us 5 minutes to walk from home to school, from home to the bus stop. And then it's going to take us m minutes from the bus stop to school. So 5 plus m gets us to school. But we also have to get home again. So now we have to go back. So we did 5 plus the m, but now we have to go back. So plus the m again, and then plus that 5 minutes again. So this would be one way we could represent that. But if you're going to do the same thing twice, instead of adding it on again, you could just do 5 plus m, which is your way to school, and then double that by multiplying it by 2. Now, if for some reason you wrote it out this way, and then you simplify that to like 2m plus 10 by combining like terms, that would be an acceptable answer as well. Okay, number 11. The length of a building is 20 feet more than its width. So in order to calculate the length of the building without a tape measure, you'd have to say, okay, well, what is the width? And you'd find the width of the building. And then it's 20 feet more than that. So that's when you add the number at the end. Okay, and then number 12 here, a piece of ribbon X feet long is cut from the original ribbon, which was 8 feet long, right? So we have this ribbon that's 8 feet long. Okay, we're cutting, there's our little scissors here. That's a really bad picture, but you get the idea. We're cutting a piece that's X feet long. And then we want to know what this is, right? So which piece do you need first? You need the entire ribbon, that total piece first, which is 8 feet. And then you're subtracting this little piece here from that 8 feet. And then that remaining piece will be left. So your expression for the remaining piece would be 8 minus X. Okay, you and 4 friends meet to have dinner at a restaurant. Everyone orders the special, so it costs the same for everybody. Write an expression for the total cost of all the meals. So total cost of all the meals. So we would have to take the number of people and multiply that by the cost of one meal, right? Now we know the number of people is actually going to be 5 because it's you and 4 friends. So you have to make sure you add yourself onto the 4 friends. There's 5 people total. And then you're going to multiply that by, doesn't give us a variable u, so I'm just going to say 5c. Or you could say 5m or 5x, whatever variable you'd like to use. So you take the number of people, you multiply it by the cost of one of the meals, and then that would give you your total. All right, the last one. You work with 5 other people at an ice cream stand. All the workers split the money in the tip jar equally at the end of the day. Write an expression that shows your share. So there's an amount of tips, right? The total tips is going to get divided by the number of people. So the total tips we'll just say is T, and then we're dividing that by 6 because it's you and 5 other people. So you plus those 5 equals 6, and that would be the expression to represent how much you are going to get. All right, so the last thing we're going to talk about in this lesson is the unit rate. So a rate is just comparing two numbers that have different units. So common rates that we use in everyday life that are actually unit rates would be like miles per gallon. The speed on your car is miles per hour typically. That is also a unit rate. Another common unit rate would be if you guys go get a job and you're getting paid hourly, or a pay rate is dollars per hour. $15 per hour maybe, or something like that. That would also be a unit rate because it's how much is happening in one unit of, typically it's time, but it can also be like some other type of measurement, like miles per gallon if you're trying to figure out your gas mileage on a vehicle or something. So in this situation, an airport checks in 460 passengers in 5 hours. So two different things, two different units, right? So when it says find the unit rate, you have to figure out, the only thing that people can do wrong here really is there's two options, 460 over 5 or 5 over 460, because you're always going to set it up as a fraction and then you're going to divide. But if you set the fraction up upside down, then you're not finding the correct unit rate. So how do you know which one to do? Well, it's always how much per something. So in this case, you'd have two options. Do you want to do passengers per hour? Are you checking in so many people every hour? Does that make sense? Or are you checking in how many hours per passenger? So if you think about it in that sense, like if it doesn't specifically tell you to find a specific unit rate, like find out, the miles per gallon or the dollars per hour or whatever, then you have to kind of think about which one makes more logical sense. So clearly in this situation, it would make sense that the rate that you're trying to find is passengers per hour. So all you have to do is take the number of passengers that are given to you, which is 460, divide that, in this case, by 5, because that's the time that's given to us, and you just simply divide it. Now with unit rates, regardless of what kind of answer you get, so if you're going to get a decimal, that's fine, because you want it to essentially be over a 1, so you have to divide it, even if it doesn't divide evenly. Now this one, we end up with 92, which would be over 1. So then that is 92 passengers per hour. Now you can write the word per, or that slash, which is like a division sign, really indicates or represents that word per. So the answer here would be 92 passengers per hour. So now let's look and try to find the unit rate for these next 4. So if we're taking a look at 15, we have miles per gallon. It's already set up for us, so we know which one's on top and which one's on the bottom. So really, it's just division. 129 divided by 6 will equal 21.5, and that's really over a 1, which is why we can now say that it's 21.5 miles per gallon. Now you can abbreviate them and do the slash. In this particular situation, you could write MPG just because that's a common, like, short-term way of writing that. That's everyone's pretty familiar with. Okay, now the next one, we're talking about how many people per tab at maybe a restaurant or something. 18 divided by 3, or 18 over 3 reduces to 6 over 1. You always want the bottom number to be 1, so you do that just by dividing on your calculator. And then we would have 6 people per tab. Make sure when you enter these on your calculator, whenever you're dividing, the first number or the top number is always what you're putting into the calculator first, and then you're dividing it by the bottom number. Every once in a while, I have people divide backwards, so really be careful. And also make sure your answer makes kind of logical sense. Like, does it make sense you would get 21 miles per gallon? Yeah, that's pretty logical. What about 6 people on a tab at a restaurant? That makes sense too. But if you divided it backwards, let's say on number 16, you would have had 0.3 repeating people per tab. That wouldn't make any sense. You can't have 0.3 people on a tab. So always look at your answer and see if it makes sense, because a lot of times you can catch a silly calculator error by doing that. Okay, number 17, 28 divided by 4 is going to give you 7. So this means $7 per ticket. Now, because money, instead of writing out the words dollars with the slash and then ticket, I just wrote the dollar sign instead. So then I wrote the word per with the ticket. All right, number 18, when we divide this one here, we end up with 200 once we get that over 1. So then this would be 200 meters per minute. Okay, the very last 2 questions here are going to be ones that are a little bit tricky, because even though they're giving you the problem in miles per hour, then they want us to find the unit rate in feet per second. So first thing I'm going to do is miles per hour. So I'm going to set that up. Now, if you wanted the answer in miles per hour, you would obviously divide those and you would get 60 miles per hour. And it's really like 60 over 1, right? But now we want to convert this to feet per second. So you might know that there's 60 seconds in a minute, and then there's 60 minutes in an hour. So if you did 60 times 60, you would get 3,600 seconds in 1 hour. So we're just going to multiply this by 3,600. And then for miles here, we need to change that into feet. And 1 mile is 5,280 feet, if you know that. If not, you could Google that or whatever. So we're going to multiply our miles by how many feet are in 1 mile. So now this is going to give us a pretty large number, I think. Let's see, I don't have my... All right, so let's just do this on the calculator, right? So if we pull out, my calculator's not open, so I'm just going to do it on my handheld here. So we have 5280 times 60, which would give us 316,800. And then of course, 1 times 3,600 is 3,600. And now we have to divide that out because this is now in feet per second. So we divide that and we end up with 88 feet per second. So your unit rate in miles per hour would have been 60 miles per hour, which is 88 feet per second. So number 20, similar. A runner travels 730 yards in 5 minutes. Find the unit rate in feet per second. So first I'm going to find it in yards per minute. So 730 divided by 5 is 146. So 146 yards per 1 minute. But because we want to convert the units, I know that there's 60 seconds here in that 1 minute. And there are 3 feet in a yard. So I'm going to just multiply the yards by 3 to get feet. So 146 times 3 is 438 feet. And then 1 minute times 60. Oh, wait, 60 seconds. Yeah. And now we can divide that and get the unit rate, which is 7.3 feet per second. And that's it. I'll see you guys for the next lesson.